Hi there, I'm Mr. Goan, and today we're going to be looking at Pythagoras skills. So, some of you may be familiar with Pythagoras. We look normally at teaching this for the first time in first year at secondary school, but it is tested right the way through to the end of National 5. That's the end of fourth year, potentially further. It features heavily in most branches of maths going on, so if you are wanting to continue maths into higher, advanced higher on into university, you do need a good firm grounding with Pythagoras. It's not too difficult to grasp once you get your head around it, and that's what we're going to be having a look at today. Now, it's important that we realize that Pythagoras applies to right-angled triangles. That's triangles with a right angle in them. Now, a right angle is 90 degrees, and it's normally marked with the little square you see in the corner there. Okay? The next important feature we need to know is that the longest side on a right angle triangle is always opposite the right angle. So we can draw a line, an arrow from our right angle, and the side opposite that is the hypotenuse. When we are solving a Pythagoras question, the hypotenuse is typically labeled C. The two shorter sides of our triangle we would normally label A and B. And it actually doesn't matter which way around A and B are, as long as C is the hypotenuse. And as you saw on the title page there, the Pythagoras equation, or our formula, is a squared plus b squared equals c squared. And that comes from Pythagoras' original formula, that the square on the hypotenuse is equal to the sum of the squares on the other two sides. So, moving on, we're going to jump straight into using Pythagoras' theorem. I'm not going to be proving that it does work or how it works. So, using Pythagoras to find the hypotenuse. This is the most common introductory style question where we are looking for the longest side. Now, in example 1, we've been asked to find x. Now, step 1, I always tell my classes, sketch the triangle, mark on this information you've been given, and then label your sides. So we've drawn our triangle. We've got information that the two shorter sides are 5 centimeters and 12 centimeters, and we know they're the shorter sides because our right angle in this corner here is pointing at our hypotenuse, which is x. Now we don't know what x is, and we've been asked to find it. So step 2, we always label our triangle. Since we've drawn it, we can label it. Our hypotenuse we should mark first is C. And now, as I said, it doesn't matter which way around we do the other two. We can jump straight in with A and B. Next up, we need to write down our formula. Now, as you get better at this, you can skip writing down the formula and jump straight into the numbers, but it's good practice to get used to it. We've got a squared plus b squared equals c squared. Now, using your algebraic substitution, we can insert the numbers we know and the letters that we are looking for into our formula. And we can reverse it. Since we're looking for c, we can put c onto our left-hand side. Now, you may see the formula written like this, straight off the bat in some other books and from some other teachers. You may see it as c squared equals a squared plus b squared. It's really up to you. Because we know enough about algebra, we know that we can swap what's on the left-hand side of an equation with what's on the right-hand side of an equation, and it still means the same thing. So let's put in our information. And don't forget about the squareds. So c is actually the letter x, so c squared is x squared. A is 5, so a squared is 5 squared, and b is 12, so b squared is 12 squared. We've put in our numbers, put in our information. We can now solve this equation. What we have here is x squared is equal to 25 plus 144, and all we've done there is square each of these numbers. And BODMAS tells us to square them before we add them together. 5 times 5 is 25, and 12 times 12 is 144. When we add them together, we get that x squared is equal to 169. And now, to reverse our squaring, we just want x on its own. We don't want it x squared anymore. We need to take the square root. Hopefully you've seen this before. It looks like a tick. So the square root of 169. We can type that into our calculator, press the square root button, type 169 and press equals. And we should get our answer of 13 centimeters. Now we can do a quick check. The hypotenuse should be the longest side on our triangle. 13 is longer than 5 and 12, so we are right, that's 13 centimeters. And that's the end of our question. Now, not all questions will be nice and simple as finding just the missing side. As you get further into the course, you will find questions have nice stories to them, solving Pythagoras in context. Our second example here, find n. Now looking at our triangle, n is now this side here on the bottom. So we start by sketching our triangle, labeling the information that we have. We know where the right angle is, it's up here at the top. We've got 8 meters on the left here and 6 meters on the right. Once we've drawn all of that in, we can draw an arrow from our right angle, and that tells us that n here is our hypotenuse C. And once again, it doesn't matter which way around, we can have A and B, or you can reverse them and have B and A. And like I said, it doesn't matter, we'll get the same equation in the end. Carrying on, we need to write down our formula. And I'm going to jump straight to c squared equals a squared plus b squared. Now, when we fill in our information, c is obviously n. So now we have n squared is equal to 6 squared plus 8 squared. We can put in that information, or we can type that directly into our calculator. If you type that as 6 squared plus 8 squared and hit equals, it will jump straight to our next answer. I'll do it by hand here for those of you without calculators. We'll have 36 plus 64, so n squared is equal to 100. Now again, to find n, we need to take the square root. So we take the square root of 100, which you should know is 10. But again, type it into your calculator and it will pop straight out. And we get that n is equal to 10 meters. Remember, units are important. If your question has units in it, so should your answer. And as you can see, 6 lines of working. Nice, simple, step by step. And as I've said, as you get better at this, there are lines that you'll be able to miss out if you want to speed up how quickly you are writing these. We won't always need to write the equation. We won't need to write this line in here, this third line. You can probably jump straight from n squared equals 6 squared plus 8 squared to n is the square root of 100. But having the in-between steps will really help with your confidence and make sure that if you do make a mistake, that it's easier to spot. Now, finding the longest side is simple enough using our equation c squared equals a squared plus b squared. What we need to move on to, though, is using Pythagoras to find a shorter side. Our formula still holds. We can rearrange it using some of our algebra skills. Now, some teachers teach straight to a rearrangement, where we can see that we start with a squared plus b squared equals c squared. So if I take b squared away from both sides, I can get a squared on its own. I can have that a squared is equal to c squared minus b squared. Now, from a solving equations background, that seems fairly self-evident. Some people jump straight to that, and that can be a stumbling block for a number of students who get confused as to where that equation has come from. The other way we can also solve this is by putting our numbers in, and what we'll end up with is an unknown lettered term plus a number squared is equal to another number squared. And then it's just an algebraic solving equations question of taking that number squared away from both sides. So let's have a look at this next question. So we have a right angle triangle here, and we can see that from the right angle in the corner, and we've been asked to find x. Now x, you can see here, is on the left, and we also have the sides 13 and 12. So let's sketch up our triangle, add on our information, and identify our sides. Here's our right angle, which makes the 13 our C. And as you can see, we've been given the hypotenuse. Now it doesn't matter which way around I label the other two, it can be A or B. My personal preference is to label the unknown A, but you don't have to do that. Now, we can put this into our formula. We currently have a squared plus b squared equals c squared, our regular Pythagoras formula. When we insert our numbers, we get that x squared plus 12 squared is equal to 13 squared. And as I said, this now looks like one of our algebraic solve the equation questions. We can solve this by taking 12 squared away from both sides, which gives us that x squared equals 13 squared minus 12 squared. And this is where BODMAS comes into it again, folks. We cannot say that 13 squared minus 12 squared is 1 squared. We've skipped the squaring. In BODMAS, the order or the indices come before subtraction does. So we do 13 squared minus 12 squared. Now we can put that directly into our calculator, but it will give us 169 minus 144, which tells us that x squared is 25. Now when we take the square root there, the square root of 25 we already know is 5 centimeters. And as you can see, 5 centimeters is the shorter of the three sides, clearly not bigger than our hypotenuse, so we know that we are in the right ballpark.